In this podcast episode, Jensen Huang, the CEO of NVIDIA, discusses the revolutionary transformations in computing and artificial intelligence that his company is spearheading. The conversation explores NVIDIA's transition from a GPU maker to a pioneer of AI factories, the complexities of extreme co-design spanning hardware and software, the strategic decisions that have shaped the company's trajectory, the challenges of scaling AI systems, supply chain dynamics, and the cultural and technological landscapes shaping innovation. Jensen also shares his personal insights on leadership, resilience, the future of AI and humanity, and the exciting possibilities that lie ahead. Jensen introduces the concept of extreme co-design as the necessary evolution in technology to address problems that cannot fit into a single GPU or even a single computer. The goal is to accelerate computing far beyond linear scaling by distributing workloads across thousands of interconnected computers. This requires breaking down algorithms, sharding data and models, and managing complex networking and system-level challenges. Success depends on optimizing every layer, from chip architectures, memory, networking, and storage to power delivery and cooling, because advances in one component alone will not yield tremendous overall speedup due to Amdahl's law. He emphasizes how NVIDIA's design process involves specialists across diverse disciplines, all collaborating intensely in problem-solving sessions. The company eschews traditional hierarchical one-on-ones in favor of collective discussions where power, memory, networking, and cooling experts challenge each other's designs in real time, ensuring holistic optimization. The company's organizational structure mirrors this approach, acting as an interconnected system whose mission and environment shape its design. Tracing NVIDIA's progression, Jensen reflects on the company's origins as a maker of highly specialized accelerators mainly for gaming, and the strategic realization that AI and accelerated computing would require a broader approach. The company transitioned to programmable pixel shaders and adopted IEEE-compliant FP32 floating-point precision, enabling GPUs to be used beyond graphics rendering into general-purpose computing. This paved the way for CUDA, NVIDIA's parallel computing platform. The pivotal and risky decision was integrating CUDA on GeForce GPUs despite the initial costs and pressure from shareholders, as it reduced gross margins significantly. This choice built a vast install base crucial for attracting developers and establishing a robust ecosystem, fueling NVIDIA's long-term influence in AI. Jensen highlights how this commitment to a unified architecture and supporting developers has become the company's most valuable asset. Jensen shares his leadership philosophy, grounded in curiosity and rigorous reasoning about the future. He believes in manifesting a vision through continuous communication, gradually shaping the belief system of employees, partners, and investors long before public announcements. This approach ensures alignment and buy-in when bold strategic shifts occur, such as going all in on deep learning or acquiring Mellanox. He contrasts this method with reactive or brand new year manifesto-style leadership, emphasizing steady, data-driven persuasion and readiness. The process involves blending engineering detail and strategic foresight to anticipate future technology trends and prepare NVIDIA to capitalize on them. Jensen breaks down AI scaling into 4 key laws: pre-training scaling, post-training synthetic data scaling, test time or inference scaling, and agentic scaling, where AI systems spawn sub-agents to increase capability. Contrary to earlier fears, data is no longer the primary bottleneck because synthetic data generated by AI itself can fuel training. Instead, compute resources and energy efficiency become critical. He argues that inference, the real-time, reasoning-intensive process of AI, is far more computationally demanding than pre-training and will dominate future AI workloads. The agentic scaling law represents a new paradigm of AI multiplicity, with increasingly autonomous AI systems collaborating and evolving. One of the most difficult technical challenges Jensen outlines is predicting AI architectural changes in advance to design flexible yet specialized hardware. The rhythm of AI model innovation, roughly every 6 months, vastly outpaces the slower hardware design cycles of 3 or more years. To keep pace, NVIDIA engages in internal research and maintains close ties with every AI company globally, listening to their needs and whispers about emerging trends. The flexibility of CUDA, continually updated and evolving through numerous versions, balances the tension between optimization and adaptability. Jensen cites examples such as NVLink 72 for high-bandwidth interconnects that enable large model scaling, and how rack architectures are continuously redesigned to fit new AI workloads, such as large language models and agentic systems. Jensen details NVIDIA's unprecedented scale, citing systems with over 1.3 million components and thousands of chips per rack, requiring an extensive supply chain of 200 suppliers. The company's growth and complexity necessitate intimate, transparent relationships with upstream and downstream partners in the semiconductor ecosystem. TSMC, ASML, SK Hynix, and equipment makers, often demanding large investments from them to keep pace. Despite these challenges, Jensen expresses confidence in the supply chain's ability to scale, driven by clear communication, mutual trust, and shared understanding of future needs. He highlights NVIDIA's unique approach of integrating supercomputer manufacturing at the supply chain level, delivering fully assembled racks rather than components to data centers. Power consumption is a critical bottleneck to AI scaling, and Jensen explains NVIDIA's relentless focus on improving tokens per second per watt through extreme co-design and energy-efficient system innovation. He envisions data centers designed to gracefully degrade power consumption in coordination with grid conditions, leveraging excess power capacity most of the time rather than demanding maximum draw continuously. Jensen advocates for contractual models and software systems that allow dynamic power allocation, where compute workloads shift or reduce speed during peak grid demand, thereby alleviating infrastructure stress. He stresses that better awareness and collaboration between end customers, data center operators, and utilities are essential to unlock large energy efficiency gains. Discussing Elon Musk's rapid assembly of the Colossus supercomputer, Jensen admires Musk's systems thinking, ability to question every assumption, minimize unnecessary components, and personally engage with operational details to drive urgency. Musk's hands-on engineering approach and leadership presence create a prioritized focus among suppliers and ecosystem partners. Jensen relates this to NVIDIA's own culture of first principles thinking and an engineering mindset that tests systems against physical limits, the speed of light principle, ensuring designs push toward the theoretical maximum performance and efficiency. Jensen reflects on China's extraordinary success in building a thriving AI and technology ecosystem, crediting their abundant top-tier AI researchers, intense internal competition among provinces and companies, a culture of sharing and open-source collaboration, and societal values prioritizing education and collective advancement. He describes China as an incredibly fast, innovating country today, with engineers often treating knowledge as a communal resource rather than proprietary trade secrets. Parallel to this, NVIDIA embraces open-source AI model development, exposing tools like Nemo and NemoClaw to catalyze broader participation across industries and countries. Jensen sees open source as vital for enabling diverse domains beyond language, such as biology, chemistry, and physics AI, ensuring that innovation permeates every sector. Jensen praises TSMC not only for its impeccable semiconductor technology, but also for its extraordinary factory management that dynamically orchestrates the complex, shifting demands of hundreds of customers worldwide. Their culture balances relentless technological advancement with exceptional customer service and deep trust, the latter being essential to NVIDIA's long-standing partnership. He recounts being personally offered the leadership of TSMC by founder Morris Chang, an honor he humbly declined to continue NVIDIA's mission. Jensen views the success of both companies as among the greatest engineering achievements in human history. The fundamental strength protecting NVIDIA from competition is the massive CUDA install base, the vast developer ecosystem, and the deep integration of the platform across cloud providers, supercomputers, autonomous vehicles, robotics, satellites, and edge devices worldwide. This cross-industry, cross-geography reach makes adopting alternative platforms costly and inefficient for both developers and customers. By vertically integrating hardware and software, NVIDIA delivers unprecedented system performance while maintaining openness to ecosystem partners. The company's transition from selling GPUs and machines to offering entire AI factories illustrates the massive scale and complexity they manage today. Jensen emphasizes the evolving unit of compute from GPU chips to full computers, clusters, racks, pods, and entire AI factories consuming gigawatts of power and requiring thousands of engineers to deploy and maintain. His vision includes scaling computation across planetary scale and eventually space-based data centers. He highlights recent product advances like the Vera Rubin pods designed specifically for agentic AI workloads and the remarkable pace of system innovation responding to evolving AI capabilities, often anticipating breakthroughs years ahead of their widespread public release. Energy remains a primary concern, but one that NVIDIA approaches through co-designed hardware-software optimization and advocating smarter power usage with the electrical grid. Jensen underscores their ability to achieve orders of magnitude performance per watt improvements, driving down AI token costs exponentially. He also acknowledges the inherent hardware design challenges due to different AI architectures emerging frequently, requiring flexibility and foresight in chip design, research collaboration with the broader AI community, and continuous evolution of CUDA to maintain compatibility with cutting-edge algorithms. Jensen speaks candidly about the tremendous pressure and responsibility of leading NVIDIA, a company integral to national security, economic prosperity, and the AI revolution. He manages stress by breaking down problems, sharing burdens with trusted teams, passing knowledge continuously, and prioritizing action over anxiety. He stresses the importance of embracing uncertainty, maintaining curiosity, humility, and a growth mindset, qualities that sustain long-term innovation and leadership. Jensen recounts moments of personal doubt, emphasizing the power of forgetting setbacks and focusing on the next shiny light or future opportunity. Gaming remains a critical foundation for NVIDIA's brand and technology diffusion, introducing millions of young users early to the company's hardware and fostering a broad developer base. Jensen clarifies misconceptions around technologies like DLSS 5, which enhances game visuals through AI without compromising artistic intent or creating AI slop, allowing developers to produce richer, customized experiences. He pays homage to milestone games such as Doom and Virtua Fighter for their cultural and technological significance and acknowledges tools like RTX Mod that enable community-driven graphics modernization for classic titles, fostering longevity and new experiences. Addressing concerns about job displacement, Jensen sees AI as elevating human roles rather than replacing them outright. He explains that when AI automates discrete tasks, the underlying purpose of jobs remains, often expanding employment opportunities by enabling higher productivity and innovation. He advises individuals, from college graduates to tradespeople, to learn AI tools and incorporate them into their work to stay relevant and drive transformation. Examples from radiology and software engineering illustrate how AI complements rather than substitutes human expertise. Jensen envisions a future where a vastly larger population gains coding and AI skills because AI lowers the entry barriers for software creation. The sophistication of specification and coding will span a spectrum from detailed programming to high-level problem design and iterative exploration with AI agents. He stresses that education should focus on AI literacy, enabling people to harness these tools effectively regardless of profession, and helping society adapt to the ongoing democratization and commoditization of intelligence. Jensen differentiates intelligence, defined functionally as perception, reasoning, and planning, from the broader human experience encompassing consciousness, emotion, creativity, compassion, and resilience. While AI may commoditize intelligence, he sees the qualities that make us human as superpowers beyond mere computation. He expresses humility about the mysteries of consciousness and remains open to surprises as AI evolves, but underscores the importance of celebrating humanity as the irreplaceable core, with AI serving as a powerful amplifier. Jensen shares candid thoughts on his own mortality, expressing a desire to continue leading NVIDIA's mission and to pass on knowledge continuously to empower future generations. He does not believe in traditional succession plans, but rather in relentlessly cultivating talent and collective capability. His optimism is grounded in a commitment to impact, a vision of technological and societal progress, and the aspiration to die on the job after delivering transformational change. Finally, Jensen expresses deep confidence in human kindness, generosity, and the capacity for profound positive change. He envisions breakthroughs in curing disease, reducing pollution, and expanding exploration to speeds approaching that of light. He believes the remarkable convergence of scientific discovery and AI-driven innovation will usher in an era of unprecedented progress. He metaphorically describes uploading his consciousness to AI and sending a humanoid robot into space, symbolizing humanity's expanding frontier, driven by technology, compassion, and relentless curiosity.